Can you solve this math challenge? Here's the question. Solve for the real value of n given that n cubed plus n squared equals 36. You can pause this video if you want to give this problem a try. And now, let's answer this question together. So, our goal is to find a real value for n given this equation n cubed plus n squared equals 36. Now, there are many ways to answer this kind of question, and here are some possible strategies. The first one is by using observation. The second is by using algebraic approach. Now, let's first start the method, which is all about observation. Now, this 36, as we observe, again, observation, as we observe, 36 is just 27 plus 9. And now, take note that 27 must be equal to 3 raised to 3, and this 9 is just 3 raised to the power of 2. So now, comparing the right-hand side to the left-hand side, we can say that n must be equal to 3. This is by observation, so we solve this question using observation. But the question is this the only real solution to this equation? So, we cannot answer that question using observation method. So now let's go to the algebraic approach. On the algebraic approach, we can now answer the question that this is, or that 3 is the only real solution to this equation. So, let's start. We have n cubed plus n squared equals 36. Again, 36 is 27 plus 9. 27 is 3 cubed, and 9 is 3 squared. We know that from the observation method. Now, what we're going to do here is to rearrange some terms a little bit. So we have now n cubed minus 3 cubed plus n squared minus 3 squared equals to 0. Now, from here, if we group this, notice that we can now use the property, the identity, a cubed minus b cubed, or the difference of two cubes. If we have a cubed minus b cubed, it is equivalent to a minus b multiplied by a squared plus ab plus b squared. And also, bc difference of 2 square. Now, if we have a squared minus b squared, it is equivalent to a minus b multiplied by a plus b. Therefore, we can factor these two terms. N cubed minus 3 cubed can be factored as follows. We have n minus 3 multiplied by n squared plus 3n plus 3 squared. And 3 squared is just 9. Now, how about n squared minus 3 squared? Using difference of 2 squared, this can be factored as n minus 3 multiplied by n plus 3. Now, take note that we have a common factor of n minus 3, so we can factor out n minus 3. Again, what we do is to factor out this n minus 3 on this factor and n minus 3 on this factor. Now, let's simplify. We have n squared plus 3n plus 9 plus n plus 3. 3n plus n will give us 4n, and 9 plus 3 will give us 12. So we have n minus 3 multiplied by n squared plus 4n plus 12 equals to 0. Now, since it is equal to 0, we can say that n minus 3 equals to 0, or n squared plus 4n plus 12 equals to 0. On the first equation, if we add 3 on both sides, we get that the value of n must be equal to 3. And we get this value using observation, right? And we know that n must be equal to 3 is correct. Now, how about on this factor, n squared plus 4n plus 12? Do we get a real value for n in this equation? Now, to check this, we will use discriminant. And the discriminant is equivalent to b squared minus 4ac. B is the coefficient of n, a is the coefficient of n squared, and c is the constant term. So, a must be 1, b equals 4, and c must be 12. So, let's substitute all those values. We have 4 squared minus 4 times 1 times 12. Now, 4 squared is just 16. 4 times 1 times 12 is 48. Now, 16 minus 48 is negative 32. Now, since the value of the discriminant is less than 0. Therefore, we don't get a real number in this equation. So we can say that in this equation, n is not a real number. Therefore, the only real number that satisfies this equation must be equal to 3. Therefore, our answer, n equals 3. And as always, we are done.